Hello. Wow, that's a lot of people. And my luck, there's always something on my screen that pops up exactly just before I present. OK, so I have an announcement to make today. But before I do that, I want to talk a little bit about Databricks. So we started Databricks because we were excited about where things were going in society. This is the dawn of advanced analytics. Soon, we might have millions, maybe even billions of self-driving cars on the street. You talk to Siri or your assistant, and it's doing voice recognition for you. And finally, AlphaGo and things like Watson are now beating humans at open-ended games. So these are not just rule-based games like chess. They're completely open-ended. This is not just sci-fi. This is important applications to companies, industries all over the world. Okay. So in particular, the same techniques are broadly used mainly to do prediction. And there's two types of predictions. One is predictive analytics, and the other one is anomaly detection. And I'll mention a little bit about these two use cases. So one, in predictive analytics, there's a whole slew of things people can do. Things like predicting product revenue for different products that you're launching. Customer assessment. You want to figure out if a customer is going to churn or not, or whether you should have a particular campaign for this particular segment. And you want to figure that out automatically using these same techniques that you saw on the previous slide. Maybe you want to figure out who you're going to advertise to, or if you're going to launch some particular campaigns. So all of these leverage data, and they're based on the same advanced analytic methods. On the anomaly detection side, you might want to detect fraud. You might want to do risk assessment. Or maybe you want to predict if some equipment is going to fail in advance so that you can go there and replace it and save those costs. So all these use cases that we see, they're all data-driven. So they would not be possible if you were not leveraging enormous amounts of data. They're usually real-time, so you need to do this in real time. And they're advanced analytics. So they're intelligent or based on machine learning. Okay? So this is great, but it turns out it's really hard to do this. It's challenging. And the reason it's challenging is today's data reality looks like this for many enterprises. Many enterprises, they have data warehouses. So they've been told for 20 years, you need to take all your data, you need to centralize it, clean it, put a schema on it, and once you have it there, you can build those apps that I just talked about in the previous slide. More recently, in the last 5 years or so, they've been told, well, actually, it's hard to get your data centralized in that one place with the structured schema and getting it to all be clean, which is right. And it's also costly, so why don't you just move it instead to a data lake? And in the data lake, you can just store all of it unstructured as it is. And you just put all your data there. It's cheaper, and then you can build those applications that I mentioned. And in recent few years, the cloud vendors come along and say, no, why don't you just centralize all your data into the cloud? Put it all there. And once you have it there, you can build those applications that you have there. So what we are seeing is that most large enterprises, they have not managed to centralize all of their data into any one of these. They have many of these projects. They are successful to some extent, but they haven't gotten all of it just in one place. So oftentimes, data will remain siloed. It's fast growing in size into these different storage systems, and it's costly. So it's really hard. And in particular, this has created the analytics gap. So there's these aspirational applications that all these companies want to build, in pharma, media, industrial. Those are the real-time data-driven analytics applications. And then there is the data reality, where the data is siloed, spread out over multiple of these places. And taking Spark and trying to cobble it or put it back down into the storage layer won't solve the problem either. If you take Spark and you put it in the data lake, then it won't be able to access the data that's in the data warehouse. Or likewise, if you're trying to directly build your applications, those advanced analytic applications on your data warehouse, then it's going to be hard too, because those data warehouses were not really built for advanced analytics. They were built for BI and doing SQL. Okay? So what is this gap? So I want to talk a little bit about the gap. The gap is, first, to get started, people need to set up data infrastructure. So what that means is there's a whole set of problems associated with this. The first one is, how do you create, tune, monitor compute clusters that can then access your data? So there's a lot of people just working on that. Then once you've done that, how do you securely access the siloed data, the data that's spread out into these multiple different storage layers? And then comes, of course, the typical handling the data governance and auditing and things of that sort. When you're done with this, you can't build just those applications I said. It's still really hard to use big data. So it turns out it's challenging. Matei mentioned yesterday the Stack Overflow survey of 50,000 people that were saying the #1 skill is learning Spark and Scala. Okay? So how do you empower your team in the organization to be more productive? How do you securely share those big data clusters that you set up in the first stage among the many analysts that you have in your organization who are maybe not trained on Spark or Scala? How do you interactively explore those data sets in an environment that's easy and accessible? And once you run into problems, how do you debug, troubleshoot, or version control these things? Having done all of this, now you have your prototype. That comes to the hardest part, moving it all into production. This is the most difficult step. So setting up robust pipelines where there's no longer any human in the loop. Everything is just running on its own, and it's doing ETL, and it's super robust. You're productionizing your real-time applications, so real-time data is streaming in, fault-tolerant, exactly one semantics. And then finally, how do you do the advanced machine learning models that you're serving? Okay, so at Databricks, we provide a cloud-hosted platform. And it's based on a few ideas that we think help advance towards these goals that I just mentioned on the previous slide. First, we have a just-in-time data platform. What that means is that we actually separate compute from storage. We don't put Spark inside of your storage system where you have it. Instead, it's in a separate, so to say, virtualized processing layer. And then we provide good integration with whatever storage system you have. So we have integrations that are secure and really fast and optimized to read data wherever you have it. And then, of course, Spark is good at caching. So the first time you touch that data, we efficiently cache it either in the memory of the computer or on the SSDs. So this enables organizations to be much more agile. So we had a customer that was taking cobbled storage and compute with Spark, and they had it in the cloud. And they said that this was falling over, and they were trying out our platform. And we asked them, how was that like? And they said, well, the problem was in the middle of the day, there would be too much queries on this cluster, and it would go down. So we had to start rate limit people in the company, saying, OK, those on this side of the building can only submit queries before noon, and other people on that side this time. And we asked, OK, so how did you solve it with this? We said, well, in this platform, we can just scale the clusters up. In a matter of minutes, you can double the size of your cluster. But that's not easy to do if you have a storage system that has storage and computation in it. Just doubling the size of that, well, you got to go through negotiations, just costly to move the petabytes of data around. So that's not easy. So this is the first thing. The second thing is, I mentioned, how do we make this stuff more accessible so mere mortals can program it? Here we have an integrated workspace. So it's a Google Docs-like environment where you can collaborate, you can plot, you can visualize, but it goes far beyond just notebooks. Here, you can actually, as you saw, Michael did yesterday when he was building his application, do real-time exploration. So if you're having a real-time streaming app, you can actually debug it. You can see what the load is like. You can do all your tuning and looking into the performance of those apps right there. You can do the same for machine learning, for graph use cases. So in short, the goal of this environment is to, as much as possible, democratize access to Spark. So more people in your organization, not just those few select engineers, can ask questions from the big data and build those aspirational apps that we mentioned in the beginning. And then finally, for productionizing your applications, we provide an automated Spark management environment where we give you workflow schedulers for machine learning, for streaming, for ETL. We give you high availability, fault tolerance, and it's performance optimized. This environment has no human in the loop anymore. There's no analyst there. But you can easily, if you want, iterate and take what you've built there and take it back to the integrated workspace where you can, again, go in and debug and go between these and iterate. Okay. All right, so pictorially, it looks like this. So you have your storage. We are not a storage provider. So wherever you have it, those projects, continue those. You have to continue managing the storage where you have it. On top of that, we give you just-in-time processing layer that's on top of this. It's virtualized. It comes and it's powered by Apache Spark. But outside of Apache Spark, we also provide you a lot of integrations that we've built into the cloud just-in-time platform. That includes auto-tuning. So we hook in to Apache Spark on those clusters, and we know the health of your cluster, and we know exactly what to tune to make sure that it's not falling over or you're getting the best performance that you can out of this. We're giving you resiliency. It's monitoring all the components that are running there. Say, if a couple of machines go down, we can replace them with new ones and make sure that your cluster keeps the same size. It's multi-tenant, so you can have hundreds of people share one cluster. So this is really the only platform that lets you do that with Spark, because these analysts that are sharing the cluster, they get to use the full memory of that cluster while at the same time being isolated from each other, so that whatever they're typing or what they're querying doesn't affect the other analyst. It comes with the data integration that I mentioned, so fast integrations with Redshift and S3 and things of that sort. And then finally, we have really powerful APIs. The APIs are really key because on top of those APIs, you can build those custom Spark applications that I mentioned earlier on top of those APIs. And we also have a BI interface, so any cluster you launch in this environment, in this processing environment, you can hook up BI tools like Tableau, or if you want to use Click, you can just connect that, and then you can do your analysis like you've done in the past. And finally, there's the integrated workspace that I mentioned. Okay. So this is what the architecture looks like. So in the beginning of the talk, I said that I wanted to make an announcement. So over the last 12 months, we've been working with a lot of enterprises, and we've seen their struggles. And one of the main things that is challenging for them is securing analytics. In particular, it remains really challenging to provide end-to-end security for enterprises, especially in this environment where your data is spread out in these different data sources in multiple different places. In particular, how do you provide end-to-end security, not just for that storage that you have, but also you need to provide file management security. You need to secure your table management if you have SQL analysts that are using them, cluster management, job workflows, ETL jobs, or this integrated workspace that I mentioned. If you have notebooks, if you have version-controlled code that you're running, how do you provide end-to-end holistic security for this? Today, there are piecemeal solutions, and you've seen those. People have provided solutions, pieces of the puzzle here and there, where you can do it, but there's nothing comprehensive in one place where you can just configure it and oversee it and make sure that it's secure. So I'm proud today to announce that we're releasing Databricks Enterprise Security, short DBES, and it will give you holistic end-to-end security for files, for tables, for clusters, for workflows, or for notebooks, dashboards, or the reports that you create. What it gives you is role-based access control on all of the components above. So this is nothing new. People have done role-based access control for many decades. But we provide it in one place. You configure those identities, and you have it for all of those components that you have above. We give you auditing and governance. So in particular, you can see fine-grained auditing of someone tried to access this particular dashboard, or someone tried to delete this particular workflow or access this file. And we also provide you integrated identity management, so things like SSO, SAML 2.0, or Active Directory. And then, of course, everything is encrypted on disk and on the wire. And the company spends actually a big portion of its energy, about 70%, on just compliances. So we're actually moving towards a superset of FedRAMP and NIST 853, for those of you who know what it is. So this is the first end-to-end security solution for Apache Spark. So I'm really happy to announce this, but I want to take my last few minutes to talk a little about use cases. So enterprises that we've seen use Databricks. And in particular, I want to highlight some of the talks that you will be seeing today at the conference. The first one is, I think, 2 talks after mine. We have Chris DiAgostino from Capital One. He'll be talking about how to do preventing credit card fraud, using the same techniques that we had in the beginning, analytics, real-time, using Spark. How do you prevent credit card fraud? This talk is, I think, in half an hour. DNVGL, Industrial IT, talking about predicting energy demand. They have massive amounts of weather data, and you use the Databricks platform and Spark, and then they can predict price and changes that are occurring. Riot Games later today will be talking about how to use the Databricks platform and Spark to predict player churn or predicting network outages based on massive data sets that they have. And there are 2 more talks, or 2 more use cases that are not talks here, but they're public on the web. Elsevier, one of the largest publishers in Europe, use natural language processing. So this is NLP on all the articles that they have, and it can figure out author graphs, who's authoring what with who, and that way you can get a recommendation on articles that you've never read. And finally, NBC Universal can generate tailored programs based on data that they have on what people view and ratings of programs. Okay, so that's it. So that's my last slide, and thank you. And I also want to say, please try this out. There's a link here where you can try out both Databricks platform and also the community edition that was announced yesterday. Thank you.